This video is about the properties of trapezoids and kites. A trapezoid is a quadrilateral with exactly one set of parallel lines. We say exactly one because we don't want to think about a parallelogram being a kind of trapezoid. We like to think about trapezoids and parallelograms as two separate shapes, and so we limit our definition for a trapezoid to having exactly one set of parallel lines. Down here at the bottom we have the parts of trapezoids. So these are base angles, and these are base angles. We think of those separately as two pairs of base angles. Okay? The parallel sides are bases, and the other two sides are called legs. Okay. Now there are some properties of trapezoids that you need to know. It is a quadrilateral, and so there are four sides. The sum of the interior angles is 360. Okay, but a trapezoid isn't a parallelogram, rhombus, rectangle, or a square, so it doesn't have any of those properties. Okay, but there is a property that is useful to us, and here's a Geometry Sketchpad file of a trapezoid. Okay, and I'll draw in the angle measurements. Okay, and we'll notice, let me find a good angle. That's good enough. Okay, you'll notice that angle A and D add up to be 180, and angles B and C add up to be 180. Okay, now that shouldn't surprise you because these are parallel, which means if you think about this as a transversal and these as parallel lines, angles A and D are same side interior angles, so they should be supplementary. And the same thing happens if you think about BC as a transversal, and these are parallel lines. Again, B and C are also same side interior angles, and so they must be supplementary. Okay, so the two angles that form same side interior angles are supplementary. Is the last property of trapezoids. Okay, there isn't a whole lot there with trapezoids. It does get more interesting with isosceles trapezoids. Okay, an isosceles trapezoid is where the non-parallel sides, the two legs, are congruent. Now let's look at some of the properties of an isosceles trapezoid using Geometry Sketchpad, and I've constructed here an isosceles trapezoid. Let me draw in the angles. Okay, and you'll not only see that the same side interior angles are supplementary, but more important than that, you'll see that the base angles are always congruent. Okay, that's one thing to notice about isosceles trapezoid. The other thing is about the diagonals. There we go. The diagonals are always congruent. Okay, those are two properties that you should be familiar with isosceles trapezoids. Okay, if a quadrilateral is an isosceles trapezoid, then each pair of base angles is congruent. Okay, again, it's only for isosceles trapezoids where the base angles are congruent. Okay, so let's find the measures of the numbered angles. If this is 77, then angle 1 must also be 77. Okay, and using the same side interior angles, I know the angle 3 must be supplementary with 77 degrees. So 180 minus 77 is 103, and so angle 3 must be 103 degrees, and angle 2 is also 103 degrees because the base angles are congruent. Okay, and I'll just do one since the next one is very similar. Okay, the other property we talked about is if a quadrilateral is an isosceles trapezoid, then its diagonals are congruent. This next idea is about the midsegment of a trapezoid. The midsegment is what you get when you find the midpoints of the two legs and connect them. Okay, and that midsegment will be parallel to the bases. Okay, the important thing to know about a midsegment is that its length is half of the bases added together, or I think of it as the average of the bases. And I see that in that it's right in the middle of the bases, and so its length will be the average of the bases, or its length will be right in the middle of the lengths of the two bases. So EF is the midsegment of trapezoid ABCD. What is X? Well, I'll set an equation. I know that 3x is equal to half of the sum of the bases. Okay, again, the midsegment is half of the sum of the bases. Hopefully you can see where all these pieces are coming from. Okay, 3x is equal to 1/2 of, let's see here, x plus 15. And I will multiply both sides by 2 to get rid of this 1/2. That cancels with that. So I have 6x is equal to x plus 15. And I'll subtract x from both sides. And 5x is equal to 15. So if I divide both sides by 5, x is equal to 3. And I was asked to find x, so I've done that. Okay, the next topic is about kites. A kite is a quadrilateral with two sets of adjacent congruent sides. And I like the fact that when most people talk about kites, they're talking about a geometric kite, okay, where there are two sets of adjacent congruent sides. Now for the properties of kites. A kite is a quadrilateral and so has four sides and the sum of the angles is 360. A kite isn't a parallelogram, rhombus, rectangle, square, or trapezoid, so it doesn't have any of these properties, but it does have some other properties. Let's go back to Geometry Sketchpad. I've drawn a kite here. Okay, and here are the diagonals. And one thing to note about the diagonals is that they're always perpendicular. Okay, if you've ever seen a kite that you'll fly up in the sky, the sticks that are used are perpendicular. Okay, let me also show some angles in here. Now there's lots of numbers changing. Okay, but notice that these are the same, and these are the same. Okay, so let me draw in exactly what is going on. ABE and ACB, these two are right here. Okay, so this diagonal has bisected angle B. ADE and CDE are down here. So again, BD has bisected angle D. Okay, but let me point out the fact that this diagonal, okay, did not bisect angle A because these are not the same. And it didn't bisect angle C because these aren't the same. Okay, let's look at the theorems that are based on these properties that we just saw. If a quadrilateral is a kite, then its diagonals are perpendicular. We just saw that. And the middle of the middle line bisects angles A and C. Okay, it's kind of hard to put that into words, so I'll just draw a picture. Okay, this middle line will bisect these opposite angles, and angles B and D, the angles between the non-congruent sides, are also congruent. Now let's use those ideas to find the measures of the numbered angles. And there are lots of them, but a lot of them are the same. Like I know that the diagonals are perpendicular, so this is 90. Draw 90. This is 90, and this is 90, and this is 90, and this is 90. Okay. I also know that this will bisect angles. It's the one that's in the middle. So this must be 46, and this must be 34. Okay, and I will next look at this triangle, and I know that 90 and 46 and what make 180. So 90 plus 46 add up to 136, and because these make a triangle, I will take 180 minus 136. I get 44 degrees. So angle 8 is 44. And 10 is 44 degrees for the exact same reason. Okay, now these angles will make a triangle. So I'll take 90 plus 34, and I get 124. And 180 minus 124 is 56. So angle 9 is 56. Oh, and angle 7 is 56 for the exact same reason. Okay, this video talked about some properties of trapezoids, isosceles trapezoids, and kites, and also a little bit about midsegments.